This video is a continuation from the lesson that we started on rate of change last class. So just to review real quick here, rate of change, to find it, you take the change in output over the change in the input. So if we look at our next example here, it says a machine at a bakery is pouring out flour. The graph shows the amount of flour in grams remaining in the machine versus time. It says find the rate of change. So if we take a look at the graph here, this notation right here looks like a triangle right here. That's the abbreviation for the word change. So this means find the change of the output and find the change of the input. So we know that the output is always our vertical axis, in this case the y-axis. So we want to know how the amount of flour in grams is changing. So if I look here, it starts at 600 and it changes. It's at 600 and then it goes all the way down to 420. So that's a change. It's going down 180 grams, and then it's changing the input, in other words the x-axis. It changes from 0, so here at 0, and then it goes to 5. So that's a change of 5. So to find the rate of change, we take negative 180 over 5. And then we would simplify it. 5 goes into both of them. And we get negative 36 over 1, which is just negative 36. So we would say for number 14, the rate of change is negative 36. Then it says interpret the rate of change in the context of this problem. So if I take the negative 36, I can put a 1 underneath. And the numerator, this came from here. So it's the amount of flour. And then the 1 is the time. So now when I interpret my answer, I could say the amount of flour remaining in the machine decreases. So I know to put the word decreases because we have a negative rate of change. So it decreases 36 grams every minute. And that is an example of a negative rate of change. Now notice, we always read a graph from left to right, so from the left side to the right side, it's going down, and the rate of change was negative. So what I want you to see from the last two examples, the one we just finished and the one we did last class, that if we always read a graph from the left to the right side, so the rate of change will always be positive if from the left, so this is the left side of the graph, this is the right, so from the left to the right, the graph is going upward. So it starts out down here and then it goes up from the left to the right. So the rate of change is positive. That's why we got a positive answer when we did number 9 with the late fees. And then when we did the problem about the flour, from the left side to the right side, it's going down. So from the left to the right, if it's going down, it has a negative rate of change. So the rate of change is negative if the graph is going downward from the left to the right. So if we take a look at number 17, It says every morning Jack arrives at 8 a.m. and parks in his assigned parking space that is 100 feet from his classroom. When he arrives to school, he sits in the parking spot for 20 minutes studying. So let's go ahead and complete this table here. So the input variable is the number of minutes after 8 a.m. And so 0 minutes after 8 a.m. So it says at 8 a.m. he's 100 feet. So 0 minutes after 8 a.m. that means 8 a.m. It's 100 feet. Well, at 8:05, so at 8:05, because it says 5 minutes after 8, he's still 100 feet. Well, at 8:10, he's still 100 feet. And at 8:15, still 100 feet. And at 8:20, it's still 100 feet. Because the problem says that he stays in his car studying for 20 minutes. So from 8 a.m. to 8:20, he's not moving. He's staying in his car. So we need to graph that. So at 0 minutes, he's 100 feet. 5 minutes, 100 feet. 10 minutes, 100 feet. 15 minutes, 100 feet. And at 8:20. So we know we're going to connect it because it says it stays there for 20 minutes. So that means everything in between. He's just sitting there for that 20 minutes. Notice I don't put an arrow there because it says that he only stays for 20 minutes. So only goes to 20. So then it says represent the rate of change as a fraction. So we're going to find the change in the output. And the output, if you have a table, is always this. So if we look at the table, how is the distance of Jack's car from his classroom changing? It's not, so 0. And then in the denominator, we have the change in the input. Well, the input is the left side of the table. So we could see that it's changing by 5 minutes every time. Well, 0 divided by 5 is 0. So whenever you have a horizontal line like this, the rate of change is always going to be 0 because your output is going to change by 0, and 0 divided by any number is 0. So all horizontal lines have a rate of change of 0. Okay, so I remember that because it has the O in horizontal. So if it's a horizontal line like this, I remember it has a rate of change of 0. Now if the line is vertical, then it's changing this way. So you'd have a number here, but then you would not change your input variable. So this time the 0's down here. So when it's vertical, you're going to have the 0 in the denominator, and any number divided by 0, we talked about this in class here, that when you divide by 0, we call that undefined. So the rate of change for all vertical lines have a rate of change that we call undefined. So that's easy for me to remember because if I write my rate of change when the 0 is under the fraction bar, the division line, then it's called undefined. So I remember it has the UND just like under does. Or I just remember that a horizontal line has a slope of 0 because it has an O in it. So then the vertical line can't be 0 then, it's undefined. Alright, so here in number 21 we have a car that is traveling at a speed of 45 miles per hour. Once the car starts to brake, its speed S is related to the number of seconds T it spends braking. So it says represent the rate of change as a fraction. So we know that the output is always on the right-hand side of the table, or we remember it as the speed of your car after braking depends on the time it spends trying to brake. So we would know that the output or the dependent variable is the speed after braking. So we need to find how it's changing. So going from 45 miles per hour, it's going to 2. So it's decreasing by 3 every time. So that's how I get the top number. And then over here, it's going up by 2. Up by 2 every time. So we have our rate of change, -3/2. And then it wants us to interpret what -3/2 means. Well, the -3 is the speed after braking, and the 2 represents the time in seconds after the car brakes. So that's what we need to explain. The speed of the car, and then the negative represents decreases. So the speed of the car decreases while braking 3 miles per hour every 2 seconds. So I'm writing the speed of the car after braking decreases, because that's what the negative represents, is decreasing. So it decreases 3, and it's the speed. So when we write speed, we write it as miles per hour, just like 45. This is 45 miles per hour. So I'm going to put 3 miles per hour every 2, and the time, it says a second, so every 2 seconds. So the speed of the car changes by 3 every 2 seconds. Okay, then it says find the rate of change in number of miles per second. So instead of 2 seconds, it wants to know in 1 second. So if we do 3 divided by 2, we'd get 1.5. Negative, since it was a negative, -1.5. So now we're asked to interpret the decimal version of the rate of change. So we would say the car's speed decreases while braking 1.5 miles per hour every second. And this rate of change was negative. So now we're asked to graph. So I'm going to take the table here and graph those ordered pairs there. So in 0 time, the speed of the car initially is 45. So we'd have 0 and 45. And then we would have 2 and 42. And 4 and 39. And 6 and 36. Okay, so since we know the car is going to continuously come to a stop, or we're going to assume it's braking because it's going to come to a stop, so we know that we're going to connect them, but we're not just going to stop there because it's going to brake. That means come to a stop. So I'm going to go ahead and connect the line all the way to the horizontal axis here, the x-axis, or in this case, the time. I'm going to go all the way until the speed of the car has brakes, so until it's 0. So that is why I don't put an arrow here, but I go all the way down to show how long it's going to take until the car has braked. So in this case, it takes 30 seconds for the car speed to be 0. In other words, it has braked. Notice that our rate of change was negative, and from the left to the right side of the graph, it's going down. So again, keep that in mind. That's going to help us when we're finding rate of change. Not forget that negative. If the graph is going down, it's negative, the rate of change. The following graph shows the number of miles from home a child is on Saturday. Use the graph to tell the rate of change for each interval as requested. Explain the meaning of the rate of change in a sentence. So as we could see here, here's the time of the day, and here's the distance from home the child is. So in other words, if we look here, we remember from the left to the right, if the line segment or the line goes down from the left to the right, it means it has a rate of change that is negative. So we know that this has a negative rate of change from here to here, so from 10 to 11, and then it goes up from 1 to 3, so positive rate of change, and then from 3 o'clock to 4 o'clock, it's going downwards, so we know it has a negative rate of change, and then from, actually that looks like 4:30, from 4:30 on here to 6, it's going upwards, so it has a positive. So that's how we can tell if the sign is negative or positive. Remember, we also talked about that anytime you have a horizontal line, or in this case segment, it has a rate of change of 0. So it asks us to explain what the rate of change is. So we're going to need to explain what the positives and the negative rate of change means. So in this problem, the graph is going down because the distance from home, he's getting closer to home. So this represents his house right here, and this is how far. So 1 mile away, 2 miles away from home. You're getting further and further from home. So the closer, so when it goes down, it means it's just getting closer to home. So the negative in this problem means you're going closer to home. You're returning to home. Whereas if the rate of change is positive, it means you're going away from home. You're increasing your distance from home. So here we're asked from 8 a.m. to 9 a.m. what is the rate of change? So from 8 a.m. to 9 a.m. So from 8 a.m. to 9 a.m. right here. It's part of that horizontal line. So the rate of change is 0. In other words, the distance from home, you're not changing. You're staying where you are that whole time. So the rate of change is 0. This means the child is not moving during this time. So the child is not moving during this time. The child is remaining 3 miles from home. Alright, next we have 10 a.m. to 11 a.m. So from 10 a.m. right here to 11 a.m. So it's going downwards, so negative. And then we have to find the change in the output to the change in the input. Okay, so our output is here. So from here to here, the child is changing 3 miles, and every 1 hour. So we would get 3, negative 3. So now we need to explain what that negative 3 represents. So if we look here, we got the distance from home was the 3. So the child is getting closer to home. So again, that's what the negative represents. So we wouldn't say the child is moving -3. The negative represents that it's going closer to home. So the child is moving towards home at a rate of 3 miles. So this is miles, it says. And then the 1 represents the time, and it's going by hours. So again, the negative means it's moving toward, or the child is moving towards home. Okay, next we want to go from 11 a.m. to 1 p.m. So from 11 to 1, the rate of change is 0 because the child is not moving. The child, if we look here, that's 0. So 0 distance from home, that means the child is at home during that time. The child is at home during this time. He is not moving from home. Okay, lastly, 1 p.m. to 3 p.m. So from 1 to 3. So we're going to find the change in the distance. So from here to here, it's positive, so I don't need a negative. And then all the way up here, that's a change of, goes all the way here, so that is 6. So 6 miles. And then from here to here, that is from 1 o'clock to 3 o'clock here, that's 2 hours. So 6 miles and 2 hours. So 6 divided by 2 is 3. So the child is moving away because it's going up. It's going away because remember this is home, the origin. It's going away. It's increasing its distance by 3 miles every hour during that time period. So the rate of change is 3. So the rate of change is 3. So it's positive because it means the child is moving away. And then the 3 represents moving away from home at a rate of 3 miles per hour. So why it's miles per hour is because this is miles and this is in hours. So miles per hour. So 3 miles per hour can be abbreviated as miles per hour.